My name is Alex Floor, and I am doing the Physics 2 extra credit video lectures for the lecture that took place on the cosmic rays Alien Invaders from Outer Space by Professor Ode. Throughout the course of the semester, there have been a lot of different video lectures, which have been really interesting, but this was definitely by far my favorite, so this is the report that I'm going to be doing it on. And also, as another note, Professor Ode is from the School of Physics and the Center of Relativistic Astrophysics. So what we were talking about was really cosmic rays, and to really understand this, we began from the beginning. So we wanted to know how it all started, and this pretty much began 100 years ago, almost on the dot, by V.F. Hess. And what happened was there were these radiation tests that were interfering with some of other tests he had, so he took a hot air balloon and flew it to the top during a total eclipse and of the sun, and what this proved was that radiation wasn't just coming from the sun, but it was also coming from the cosmos. And for this discovery, he won part of the Nobel Prize back in 1963. But this really opened up all these doors for questions. Where do these cosmic rays come from? What does this mean? Is it healthy? And what other effects do they have? So he also looked at what are cosmic rays like in everyday life. And they contribute to a large amount of the natural radioactivity that we receive every day. There's a certain percentage each year of radioactivity we receive, and most of it is from the sun and the cosmic rays. And there's a large portion of people that die each year from cosmic radiation. I remember reading about that somewhere else with like skin cancer and things like that. I think it's like 100,000, but I think it's 100,000. But it also helps with radiocarbon dating, which I thought was really cool, and I didn't know that before. And C14 is produced by cosmic waves, and in the radio, and that's how it's created for carbon dating and stuff. And it is also highly interactive with our electronics, which means, if we have more electronics in a smaller space, they start to interact with each other, and the cosmic radiation affects that, and you have to be careful. The equipment you're using, within the space of it, and within the distance of cosmic rays. And another thing, which explains by the picture, but cosmic rays, they provide these seeds for when lightning strikes, provides the seed for lightning to go down with. If lightning took the easiest path to go down, I think it'd be straight. But no, it actually follows the seeds that are left by the cosmic rays. And he also went into the cosmic ray spectrum, which was really interesting. And this spectrum is a flux versus energy. And if you look at the degrees of the multitudes on this, they're not normal, as you would say. So you assume that there are different sources of cosmic rays. However, there is really no difference in the change of flux noticeable, which is curious, which suggests that there is multiple sources for the cosmic rays, as shown in the chart. So now it asks the big question, where did it come from? So we know the cosmic rays come from high in the atmosphere, and there's this new idea of the relativistic particles that are shown, and actually most of the cosmic rays are mostly protons, and the closest replica we have on Earth is a particle accelerator. But as they decrease in the atmosphere, they start to expand, and the shapes, locations can be extrapolated as they go out. So another slide that was shown this is our electromagnetic spectrum, and you said we have the visible light, which is around 10 e to the negative 6 wavelengths, and then so on and so forth. But the interesting thing about the cosmic radiation is the high energy and the very high energy gamma rays, which we'll talk more about gamma rays later because they really affect the cosmic radiation. Bands go even higher, from like 1 GeV to 10 TeV, so they're like way out on either side of the electromagnetic spectrum, which was interesting because we've always seen this electromagnetic spectrum, and I thought that's what we have, but no, it expands way farther than that. So again, the whole question is, where did they come from, and how do we find them? How do we trace them? So the tracing that we have, some of them doesn't work right now, such as at the Pierre Auger, excuse me for that, observatory, which is in South America. And it is an observatory that covers 3,000 square kilometers, and it's these big open fields with all these different devices set up to track the cosmic radiation that goes through. And there's also, and another different way that can track it easier is ice cube neutronio detectors. And being in the ice increases the energy, so they're like either ice caps, and this is when they use gamma rays. And only some of the gamma rays, though, can lead to the connection of the cosmic rays. So they have these devices, and the picture to the bottom left is one of the ice cube neutronio detectors. So news about gamma rays. So as you can see, the picture shows the intake of cosmic rays, and the spots are the sources of different stars, black holes, and numerous supernovas. So as the 100 years of, since the beginning, we've learned a lot, and we're really, we've gotten towards the idea that exploding stars are the source, and you can see these different spots on here represent, the supernovas, the black holes, and the different stars on here. And so to conclude this, and what was really he was getting at toward the end of the presentation is, what's new? What have we, how have we changed these past 100 years? And even though we're still unsure, we're not as unsure anymore of where it comes from, but we're still trying to grasp what actually cosmic rays are. And there's been questions like, could this cause global warming? Well, no, that was not proved. It doesn't have an effect on that. Could it? And some more ideas saying, could it be dark matter? And could cosmic ray debris and dark matter be related? Which is, a big topic of conversation right now. And they found that the sources actually show that cosmic radiation does come from exploded stars. And so this is really cool, and the effects that, the different stars in the universe have on us, even across these, vast distances. So it was a, great presentation. I really enjoyed all these lectures, but this was, by far my favorite. So this was my lecture. Well, not my lecture, but, my take on the lecture, so I hope you enjoyed it.